All right, today we are going to tackle 3.1.3. A couple key learning targets. One of them is going to be just a repeat from what we did on Tuesday. So I'm going to get a little lazy and just draw an arrow there. We don't need to write that out twice. So one of our key learning targets, again, is going to be to write and solve proportions. We talked about solving proportions at the beginning of class. That was our little warm-up problem. This writing part is going to be the part where it's really easy to make some mistakes. Usually my students get really good at solving, but they make frequent mistakes with the writing. So I'm going to teach you some ways today to double check to make sure that your proportions are written correctly, because there's no point in solving something if you don't get the right equation written. The second thing is I want you to be able to check for similarity. If I give you two shapes, I need you to look at those two shapes and either say yes, they are similar, or no, they are not. So Tuesday rather, we started talking about the idea of similarity. Do you guys remember what we said? Similar shapes. What was special about similar shapes? Something is the same about them, but something else is not the same. Yes, so they're not exactly the same is a great way of saying that. When we're talking about two shapes that are similar, what is the same about those two shapes? Yeah, so they're going to be the same shape. If one's a triangle, the other one's going to be a triangle, right? But they could be two different sizes. One can be bigger than the other. One of the biggest uses, we talked about this in my 8th period class yesterday, one of the biggest uses for similarity in the real world, what do you guys think it is? Yeah, modeling stuff. Where would you see similarity on say a construction site? Blueprints, right? If you're going to build a building, you need to know what the building's going to look like. Well, blueprint's going to give you an idea of what the building looks. It's going to be in the same shape as the actual building. It's on a big piece of paper, but obviously it's not the same size as the actual building. So similarity comes into play there. So I want you to be able to check for similarity. The other key thing about similarity is similar shapes have matching ratios, and we're going to be looking at that again. So if you guys will flip back, I want to remind you about this problem that we looked at here. We were looking at these two shapes that were similar. They're the same shape, but one of them's bigger. And we created ratios for the corresponding parts. The 24 and the 8 match, we put those into a fraction. The 18 and the 6 match, we put those into a fraction. And what did we find about those two ratios when we reduced them both? They were both the same. They're equal to each other. Okay, so that's the key thing. So for our first problem, I would like you to look at these two rectangles and tell me, and let's ignore part A for right now. Let's focus on carrying over from Tuesday. Tell me, how could you know that they are similar? How would we know that they are similar? How could we prove it? I'll give you a hint. The way we're going to prove that they're similar is we're going to find a couple of ratios. And we're going to show that those ratios are the same. So let's start with the 2 here. What corresponds to the 2 on the other rectangle? The 7 and the 2 correspond. Agreed? Could you please put 7 and 2 into your first ratio? Now, I'm going to tell you, it does not matter what order you do it in. On Tuesday, I told you, let's do the new one on the top and the old one on the bottom, but it really doesn't matter. In fact, I'm going to flip it around today. I'm going to put the 2 on the top and the 7 on the bottom. If you put the 7 on the top, that's okay. All right, we've got another pair of corresponding sides, 6 and 21. Could you please get the 6 and the 21 into your other ratio? Now be consistent. This is the part, remember a moment ago I said solving proportions was easy, but setting them up causes mistakes sometimes? This is where it's easy to flip things around. So on mine, I noticed that I put the 2 on the top. The 2 is the smaller of the two numbers, agreed? So if I'm going to be consistent, when I do my 6 and my 21, I also want the smaller one on top. I did smaller one on top here, so I'm going to do smaller one on top here. I did bigger on the bottom here, so I'm going to do bigger on the bottom here. And I'm going to go back and double check because I have made this mistake so many times that I just want to make sure I'm not making it again. Am I being consistent? Smaller on the top, bigger on the bottom, smaller on the top, bigger on the bottom. I'm being consistent. Okay. All right. Now, if those two shapes are similar, then those two ratios should be identical. Can you reduce? I don't think we can reduce 2 over 7, can we? Can you reduce 6 over 21? What are both of those divisible by? We could divide them both by 3 and we would get 2 over 7. Ooh. So are these two shapes similar? Yes, they are. How do we know they're similar? Because the ratios of the corresponding sides are equal to each other. I just wrote that backwards. Pardon me. The ratios of the two sides are equal. If you don't like doing the whole reduction thing, we could have also done this. Grab a calculator and type in what is 2 divided by 7. It's that big old number. And then go to your calculator and do 6 divided by 21. Oh my gosh, it's the same number. Those two ratios are the same. Okay, this is asking what other ratios we could use. Did anybody do 7 over 2 instead? And they were still the same, weren't they? So I could also have done 7 over 2 equals 21 over 6. That would work. There are actually 2 other ways we could write this ratio. Did anybody think outside the box and write these 2 ratios in a different way? Now, I'm not a big fan of this because it tends to confuse me when I do it. What if I had put the 2 here and the 6 here? What do you suppose I would do with I've got to do the 7 and the 21 here. Where would you think you'd put the 7? Top or bottom? And 21 down here? This looks a little bit weird to me because I'm not matching up the same sides. I'm doing the same shape in one of my ratios and the other shape in my other ratio. But am I being consistent? I'm doing 2 over 6, and then I'm doing 7 over 21. Is that consistent? So that would work as well. I'm not a big fan of that. I like these better. All right, go ahead and read what it says about Lynn down in part D. Lynn does not think they're similar. I just want to understand Lynn's thinking. Lynn is thinking that they've got 2 over 7 and they've got 21 over 6. And if I grab a calculator and I try and make some decimals out of that, 2 over 7 is about 0.29. And 21 divided by 6 is about 3.5. And those don't match. They're not equal to each other. So Lynn's saying because the ratios are not equal, they're not similar. What mistake did Lynn make? Didn't stay consistent? You want to add on to that? Good, I like that. So same idea. You said consistent, and that's the key. That is the key word. Lynn was not consistent. She did the smaller on top here, but then she did the bigger on top over here. But do you see how it's really easy to flip that? This is where people are going to have trouble when they go to do the next thing that we're going to do. So please always double check and make sure that you're being consistent when you write it. Okay? So 2 ways Lynn could fix this. Either Lynn could flip this over. Now it's the bigger on top in both of them. Or she could have had the smaller on top in both of them. All right, we feeling okay so far? One of our big learning targets today is if I give you a figure, two figures, can you tell me whether they're similar, yes or no? Are we feeling pretty good about that? How are you going to do it? You're going to make a couple fractions. And if those fractions are equal to each other, then they're similar. And if they're not equal to each other, then they're not similar. We got it? All right, the second learning target was, can I set up and solve some proportions? So that's what we're going to have to do in number 25 here. I'm going to walk you through the first one, and you guys are going to do the next two on your own. So please pay attention as we go through the first one. Let's read the instructions. It tells us that each pair of figures is similar. If we know for a fact that these two things are similar, then our ratios must be equal. So we know we can stick an equal sign between those ratios. So let's write ourselves an equation with those ratios on both sides. Do you guys remember what these equations are called that look like this? Starts with a P. An equation with a fraction on both starts with a P. Proportions, thank you. All right, let's see if we can write an equation. We got four things here, the 2, the 6, the 4, and the x. There's lots of ways we could do this. Which one do you want to put on the top and the left? Pick any single one of those four things. It does not matter. We can make it work any way we do it. But somebody pick. So you're 2? Okay, let's put the 2 up here. So let's go corresponding sides. What does the 2 correspond to? 2 corresponds to 4. It's easy to see in this picture. Now, it might not be so easy in some of the other ones because they're going to spin them around on you, but we got this. So we got 2 and 4 in one of our ratios. We're going to have to get the x and the 6 in the other one, and we need to be consistent here. Now, I don't know which is, I know that we're trying to get the smaller number on the top, but I don't know what's bigger, x or 6, because I don't know what x is yet. But can you look at the picture and tell me which one's bigger? X looks like it's bigger, right? And over here we have the bigger one on the bottom. So should we put the x on the bottom? I'm not feeling so certain here, guys. Can you double check and make sure that I was being consistent here? I did the smaller on the top here. Is this the smaller side on the top over here? I did the bigger side on the bottom here. Is this the bigger side on the bottom here? I think we're good. I think we're good. All right. Please, please, please get in the habit right now of double checking every time you write one of these down. That's where you're going to make mistakes, okay? And I would bet that every single person in this room is going to make that mistake at some point during this unit, okay? Go ahead and make it early, get it out of your system. We certainly don't want to do it on the test. Get in the habit of double checking. Okay, we know how to solve these, right? We know how to cross multiply. Let's do it. I'm going to multiply the 2 times the x. That's 2x. I'm going to multiply the 4 times the 6, which is 4 times 6 is 24. And then I'm going to divide by 2 on both sides. And I'm going to get x equals, spoiler alert, it's 12. I'm going to pause for questions here before I move on, and then I'm going to ask you guys a question about this. Please do not work on part B yet. If you've started, just pause for a moment. There's some important information I need to get you. Are you not feeling well enough to keep your head up in class? Do you need to go to the nurse's office? You're good to go. Okay. Keep your head up, please. Thank you. What questions do you have for me? I got questions for you. All right, here's my question for you. How could we be sure that our answer is right? How could we check? What do you think? I heard someone say something. Yeah, we could go back and we could put this 12 in here and see if it works. How can we make sure it works with the picture? When I do these, if I figure out x is 12, I'm always going to put it back in the picture. And this is why I want you guys to start drawing. When you're doing your assignments, please draw the pictures on your page. Because it allows you to go back and do a pretty quick check visually. If this is 2 and 4, does it make sense that this would be 6 and 12? Does that seem reasonable? It does. Now, if I had flipped these around, okay, if I had written my proportion incorrectly and I forgot to double check it, when I did my math, I would have come up with the answer of 3. If I put a 3 here, would that make sense for this picture? No way that's smaller than this, right? So writing it on the picture helps you. All right, here's my second question. I need everyone's attention up here right now. All right, some of you guys are thinking like you've got an easier way to do this. I know, I can tell it. I can read it on your faces. In fact, anybody want to be brave? How many people in here think, I didn't need to do any of that? If I had looked at that picture and just thought about it for a second, I could have told you x was 12. How many people feel like you could have done that? Maybe you already did as soon as you looked at it. Can somebody tell me their reasoning? What mental reasoning did you do to come up with that answer of 12?
Well, it's the same shape. Mm-hmm. The 2 is just, the 4 is just 2 doubles.
Yeah. This is twice as big, right? So then this must be twice as big also. Boom, we got our answer. Right? Okay. Now, here's the question that some of you are dying to ask me. Actually, you're not, because you know you're not going to be happy with the answer. But I want to make sure you guys all hear the question and the answer. If I can do this problem without writing a proportion and solving it, is that okay? And for right now, my answer is no. I want to see a proportion and I want to see you solving it. Okay? Thank you for anticipating my answer. Does anybody anticipate my reason for that? I would like you to try, let's meet in the middle, okay? I like compromise. If you've got 3 of these problems to do on your assignment, would you do one of them with cross multiplication and then do the other 2 the other way? Would you meet me in the middle on that one? The reason is cross multiplication is going to make, there are some things that you're going to see later on, and I'm thinking about algebra 2 right now, where if you know cross multiplication, you're really comfortable with it. It's just going to make your life easier. Does that answer work for you? Thanks for meeting me in the middle on there. Do you know my reason for asking you to set this up and solve it? It's because you're not always going to be able to look. It's not always going to be this blatantly obvious that you just double everything. Okay, you're going to have to do this at some point. I'm going to ask you guys to please practice doing it this way at this point. Okay. So what your job is right now is to go ahead and solve parts B and C, and then please do number 26. And when you're done with all those, just put your hand up in the air, and I'll look them over and start your assignment. Okay, and you don't have to wait for me to look at your work to start your assignment, but make sure that you get my attention as soon as you can so I can check your work. We are going to come back together and talk about the answers for the rest of 25 and 26, but for right now, I think you guys got what you need to get after it. Any questions for the greater good? All right, I'm going to come around and be stamping assignments while you're working on this. And then I'll also answer questions as we go. If you got a question. All right, let's make sure we're good to go here. There's a lot of different ways that you could write this proportion. But I'm hopeful that you matched x up with 6. If you put the 6 on the top and the x on the bottom, that's fine. But did you guys match those 2 things up? Folks, please have your packet out. Make sure that we're getting what we need to get here, okay? I love that a lot of you have already started the assignment. But let's make sure you're learning what you need to learn. It's our main target today. X and 6 would match up, and then 3 and 4 also match up. So I'm going to put the 3 here and the 4 here. Does that look right? Can you guys double check that for me, please? X goes with 6 and 3 goes with 4. Whoa, what did I do wrong? Oh, I better check and make sure I was consistent now. On this one I put the bigger shape on the top and the smaller shape on the bottom. Did I do bigger shape and smaller shape? No, I did not. I flipped them over. Oh my goodness. It is so easy to make that mistake. Did anybody also make that same mistake? All right, can I show you guys my little trick for checking here? This makes it a lot easier for me. And it just takes a second. Half of you are interested. Okay, I'll take half. The rest of you guys can miss these problems on the test 50% of the time. All right, so here's how I do it. I always look at the columns and then the rows. So if I look at the x and the 6, my first question is, do x and 6 match? Yes? And then I'm going to look at the 3, 4 column. Do 3 and 4 match? Yes. So my columns are consistent. And then I go back and I look at the rows. X and 4. Did X and 4 come from the same shape? Yes. 3 and 6. Did 3 and 6 come from the same shape? Yes. All right, so what I'm looking for in my rows is same shape. And what I'm looking for in my columns is do the sides match? If you do that check really quick before you start solving, you're going to avoid that super common mistake. Spoiler alert, x ends up being 8 for this. This next one was tricky. They told us the perimeter was 60. If you know the perimeter is 60, you should be able to figure out what this side is. I know that rectangles have the same length on the top and bottom, so 21 and 21. That means I'm using up 42 out of my 60. How much more do I have left to add on to 42 to get 60? 18. But that 18 needs to split up into both of these two sides, so what's it going to be? 9 and 9. So this ends up being 9 and 9. So we did a little bit of work to figure out what that was, but now we can start setting up a proportion. All right, I'm going to go with 3 and 9 because they match. I'm going to go with x and 21 because they match. I've checked that they match. I'm going to check my rows now. Did 3 and x come from the same shape? Yes. Did 9 and 21 come from the same shape? Yes. We're good. Solve this one and you're going to get, I don't know what we're going to get for that. 63 divided by 9 is 7? Oh yeah, that's 7. Yeah. X equals 7. Now, I'm not showing the cross multiply part because we've gone over that, but if you need some help with that, please let me know. You guys, I asked you to do 26. Did you do 26? Let's talk about it. They said draw a larger U with a scale factor of 3 over 2 or 1.5. Now, they didn't say where the center was going to be. We just need to make sure that each of the sides is 1.5 times as big as the original one. So I'm going to just kind of start it right. I'm going to start up in this corner. This top is 2. 2 times 1.5 is 3. Down the side here, 1, 2, 3, 4, 5, 6, 7, 8. What's 8 times 1.5? 8 times 1.5 is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, we're going to end up using the whole thing. The bottom here I've got 1, 2, 3, 4, 5, 6. 6 times 1.5 is, half of 6 is 3, so 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That should go up to here. That should go like that. And then how far down is this going to go? This distance here is 2, so that's 2 times 1.5 is 3. So I think we're going to end up with something like this. Yours might look a little different because you might have started yours at a different spot. Probably would have been much easier if I did it on a separate piece of graph paper. What do you think? Yeah. Anyways, they want us to find the ratio of the perimeters. So to find the ratio of the perimeters, we would need to go back and add up in our original shape the total perimeters. The perimeter for the original shape was 2 plus, this was 8 plus across the bottom we had 6, another 8 here, another 2 here. Down the side here was 6, another 2 on the inside here, and then another 6 up the side, for a grand total of what? 24, 26, 32, 34, 40. Did you guys get 40 for the perimeter? So my original U had a perimeter of 40. What will we multiply that by to get the new perimeter? 1.5. 40 times 1.5 is 1.5 is 60. So the new perimeter would be 60. So the ratio of the new perimeter to the old perimeter would be 60 over 40, which does work out to be 1.5. Casey enlarged the U proportionally so that the new height was 10. I'm going to write myself a ratio here. We're going to put new on the top and old on the bottom. The new height was 10. What was the old height again? It was 8? If I counted from top to bottom, yes, it was 8. So what's my scale factor? Yeah, it's whatever 10 divided by 8 is, which is 1.25. All right, I did not ask you to do 27, but let's talk about it really quickly, and then we're done, guys. Look at 27. Don't miss this. Please don't miss this. This is going to become important for what we're doing next class. This student took this diagram number 1. It was a 60-degree angle, and they enlarged everything by a factor of 2. Does that mean that this is a 120-degree angle? Yes or no? Does it look like 120 degrees? 120 degrees would be bigger than 90. Does this look like it's bigger than 90? You guys are missing something that's going to just absolutely confuse you like crazy next class if you don't pay attention, okay? Thank you. So when I enlarge an angle, when I enlarge the sides of the angle by 2, does that mean that the angle actually multiplies by 2 also? The answer is no. If I asked you to guess how big this angle was, what do you think it would be? It is 60. This is key. This is important. When we do a dilation, it changes the lengths of things. Does a dilation change angles? Keep that in mind. That's going to be really important for next class. All right, guys. Thanks for your attention to your work today. Monday, we're going to go back to 3.1.4. Ooh, 314. That's like pi. And it's going to be awesome.